Greetings, everybody. Let's take another look at an example using integration by parts. So suppose somebody gives us an integral and says, hey, I need you to evaluate the integral of the natural log of x. Now, this one is a little bit different in that it doesn't look like we actually have two separate functions, but really we do in this case. And the two separate functions, if we look at it in the right way, are really just 1 times the natural log of x dx. And so if we want to use integration by parts on this, what we're looking at, again, kind of coming back to our acronym LIATE, that we have logs, we have inverses, we have algebraic functions, we have trig, and then we have exponential. And so in this case, what we've got is a log function in our natural log, but then we also have an algebraic function in 1, so just the constant 1. So it's a polynomial of degree 0. It's going to be an algebraic function. And so what that tells us is that u is going to be our log function, and then dv is going to be everything else. So if we take u to be the natural log of x, dv then becomes 1 times dx, so that our du, which is just the derivative of u, so the derivative of natural log, we get a 1 over x dx. And then for v, we get the antiderivative of 1, which is just plain old x. So this is kind of our setup, and now we've got our integration by parts formula. So just to write that out, so we've got u dv equal to u times v minus the integral of v du. And so that's the integration by parts formula that we are going to use. All right, so the setup for what we had, we're evaluating the integral of natural log of x. And so we chose u to be our natural log of x, and we chose dv. Then by choosing u to be natural log, dv then just becomes everything else. So our du was, again, our 1 over x dx, and v being the antiderivative of dv is just plain old x. So then our integration by parts formula, we have the integral of u dv is equal to u times v minus the integral of v du. And so what this leads us to, so now just kind of following that formula, we've got u times v, so that's going to be x times the natural log of x minus the integral of v du, which is just x times 1 over x dx. And so what happens in the second integral, our x's cancel out at that point, and so we're just left with x times the natural log of x minus the integral of dx. So in this case, we know that we've made a good choice for u and v because our second integral does become easier at that point. And because it's easier, that tells us, yeah, we're probably on the right track, and that was the direction that we wanted to go. And so just evaluating that second integral is just going to give us x times the natural log of x minus the integral of dx, which is just going to be x plus our arbitrary constant. And so with that one, we've actually found a formula now for the integral of natural log. And so what this gives us then is the integral for natural log of x. We've actually found the formula for that one, just being x times the natural log of x minus x plus our arbitrary constant. And so this kind of becomes a handy formula that we have if we ever kind of need to use it on its own, just in ordinary circumstances. So the formula for integration by parts actually then gives us the formula for the integral of natural log. So I hope this has kind of been an informative example, and I will see you guys next time.